Hi, my name is Malik Boudiaf and I'm a PhD student at ETS Montreal. And today I will be discussing our work on few-shot segmentation. But first, let me describe the few-shot segmentation set. So in this setting, you are given access to a fully annotated training set with the set of base classes. And at test time, the model is evaluated based on its ability to generalize to unseen classes. Specifically, a series of episodes are created, where each episode consists in first sampling a class that has never been seen during training, and second sampling a support set with one or multiple annotated samples for this class, and finally sampling an unlabeled query image. And the goal is to properly segment the object of interest in the query image. Now let us discuss the motivations for our work. So the first one is that there's been several issues recently associated with episodic learning in both few-shot classification and few-shot detection literature. But there's been no attempt to propose a non-episodic baseline for few-shot segmentation yet. The second one that I'd like to discuss a bit more in details is the introduction of the transductive setting. So particularly in few-shot classification, there's been a significant number of transductive methods proposed in the last couple years, and often outperforming by far the inductive ones. But does this setting make sense for few-shot segmentation? Well, to answer this question, let us draw a quick analogy between classification and segmentation. So here is a typical few-shot classification task with the labeled support sample and unlabeled query images, and a pre-trained model. So essentially what the transductive learner does is take those three elements as input and produce a final classifier for this task that can then make predictions for the query set. So if you paid attention, we are here assuming access to the full query set prior to building the classifier, which can be deemed unrealistic in some applications. On the other hand, if we interpret few-shot segmentation as a pixel-wise classification, then this assumption just boils down to assuming that you have access to all the pixels in the query image, which is always realistic. So all in all, the answer is yes, this setting completely makes sense for few-shot classification, and actually it makes even more sense for few-shot segmentation than it does for few-shot classification. So our contributions in this work is to propose the first non-episodic baseline for few-shot segmentation and to produce new state-of-the-art results for the 5 and 10-shot scenarios, as well as in our newly introduced domain shift scenario. So now let me describe our proposed transductive inference that we call REPRI. Let's consider a task and a frozen encoder that's been pre-trained with standard cross entropy on the base classes. First thing we want to do is build an initial classifier using the standard mean average pooling on the support features. Then we want to fine-tune this classifier. So first we can naturally leverage supervision from the support set by simply minimizing a cross entropy between the labels and the prediction of our classifier. Now for the transductive part, it is common to use the entropy of predictions as an unsupervised criterion, but this typically leads to very poor results in our case, with the background completely taking over the foreground. At that point, we propose to regularize the proportion of predicted foreground and background to match a certain parameter pi, and this pi is jointly learned with the rest. So we provide more details in the paper on how this is done. Let us now look at the result and try to uncover three main messages. The first is that our method seems to better leverage supervised information from the support. As you can see, the gap with respect to SOTA methods is basically widening as the number of shots increases. Second message is that having access to the exact foreground-background proportion seems to bring impressive improvements with respect to state-of-the-art, which we hope could motivate further research in the future. Finally, we introduce a domain shift scenario, and we observe that our method seems to be more robust to this type of domain shift than existing methods. So as a conclusion, well, the main takeaway is that first, this transductive inference seems to be very promising for the few-shot segmentation setting, and we encourage future methods to use that. And second, that the episodic learning needs not be the best way to tackle few shots in general, as we demonstrated with our methods. So in the future, we hope that the research could tackle and try to propose new methods to estimate in a more principled and accurate way our parameter pi, and perhaps extend our work to multi-way scenarios. So thank you very much for listening, and see you at the poster session.